Hi. Now, you're often going to come across second order differential equations which aren't of a particular form, but by using a substitution we can convert it to a linear second order differential equation which we can then go on to solve. And in this video what I want to demonstrate is how we can use a given substitution to perform this operation. So for this question we've got to take the substitution x equals root t, change this differential equation into this one here. And so what we do is we start then with our substitution, in this case x equals root t, which I'm going to change to t to the power half. Now we need to find dy by dx and then later d2y by dx squared. So for finding dy by dx, let's just pop this down here, dy by dx, we use the chain rule. Dy dx is going to be equal to dy by dt multiplied by dt by dx. Now to get dt by dx, we take x equals t to the half and differentiate this with respect to t. So it follows that dx by dt is going to equal a half t to the power minus a half, or 1 over 2 t to the power a half. So for dt by dx we just need to reciprocate this, so that's going to equal 2t to the power half, and then we multiply that by dy by dt. Now I'm going to need dy by dx as a substitution later on. So what I'll do is I'll call this number 1. We'll come back to that later. Next, I want to work towards d2y by dx squared. So to get d2y by dx squared, again, what I'm going to do is need to differentiate with respect to x, okay, what we have here, dy by dx. So let's just put that in square brackets. 2t to the power a half multiplied by dy by dt. And again, we're going to need to use the chain rule here. To differentiate this with respect to x, we get round it by just saying we're going to differentiate it with respect to t. Okay, let's just put this in again. 2t to the power half dy by dt. But we're differentiating it with respect to t, and now we need to just multiply this by dt by dx. So the chain rule again, and you're going to find you're going to need to use the chain rule quite a lot in questions like this. Okay, so to differentiate 2t to the half dy by dt with respect to t, we're going to need to use the product rule. So I'll take the first part here, 2t to the power half, and if we differentiate dy by dt with respect to t, that's going to be d2y by dt squared. And then, still using the product rule here, I take the 2t to the power half, I'm going to differentiate this now, so half times 2, that's just the 1, and then you've got t to the power minus a half. And we multiply this by dy by dt, so just put that there. Okay? And all of this is being multiplied now by dt by dx. So what is dt by dx? Well, we've got dx dt, so dt by dx is just the reciprocal of this, 2t to the power a half. Okay? Now I'm going to expand this bracket, so if we multiply through, we've got, well, just recap and say that this is d2y by dx squared, but if we expand the bracket, 2t to the half then times the first term here is going to equal 4t times d2y by dt squared. And now if we multiply 2t to the half by this term here, what we get is plus 2 dy by dt. So now, what we need to do, let's just call this 2. What we need to do is substitute our values 1 and 2, and also for x equals t to the half into this equation up here. Let's call this equation, say, a. So what I'm going to do is sub 1 and 2 into equation a. And what does that give us? Well, we therefore have, for d2y by dx squared, we're going to have this chunk here, so we'll just write that in, 4t d2y by dt squared, and then plus 2 dy by dt. Next, we've got minus 1 over x times dy by dx. Now, minus 1 over x, but x is t to the half, so I'm going to substitute that in. So that's 1 over t to the power half, and then that's multiplied by dy by dx, so we can use 1 here. So that's 2t to the power half, and then dy by dt. Next up is plus 4x squared. X squared is going to be just t, so we've got plus 4t, and that is being multiplied by 9y plus 6, so 9y plus 6, and all of that equals 0. So what do I notice? Well, I notice is that the t to the half here cancels out with the t to the half here, just leaving us with that 2. And now we've got plus 2 dy by dt minus 2 dy by dt, so that's going to be 0 here. So let's just write down what we've got now. We've got 4t then d2y by dt squared, and then plus 4t multiplied by 9y plus 6, and that equals 0. And I now notice that I can cancel through by 4t. That goes once, and that goes once. And I've essentially now got what we're looking for. I can see that therefore d2y by dt squared plus 9y, okay, and then I've got plus 6, but if I subtract 6 from both sides, it's going to equal minus 6. So the substitution then has enabled me to convert our second order differential equation to a more familiar form, a linear second order differential equation. Alright? And now we just need to go on and find the general solution. So let's just take on that general solution now. So when we've got something like this, we need to first of all work out what the complementary function is, CF for short. So the complementary function is found by solving d2y by dt squared plus 9y equals 0. And if that's the case, we need to work out our auxiliary equation. We'll just put AUX, okay, equation for short. And that would be m squared plus 9 equals 0. And that would lead to m squared equaling minus 9, which is then going to lead on to imaginary roots. M equals plus or minus 3i, I being the root of -1. So our complementary function is going to be of the form y equals a constant, a, times the cosine of 3, and then it will be t, plus another constant we'll call b, sine 3t. Okay, so that's our complementary function. We next need to go on to work out our particular integral, pi for short. So we need to say let y equal something, and because we're dealing with a constant here, and a constant as a term isn't in our complementary function, then I can say let y equal, say, a constant lambda. So we can differentiate this. We can say that therefore dy by dt would equal 0. And so would d2y by dt squared. That would equal 0 as well. So if I take this equation here, our original equation, let's just call it 1, okay, and we substitute these values into 1, okay, substitute into 1, then what we've got is, well, this is 0, and then we've got 9 lambda equals minus 6, so 9 lambda equals minus 6. And from this, it follows that lambda must be equal to minus 6 over 9, or minus 2/3. And we can substitute this back in to get our general solution. Our general solution will be the complementary function, this one here, a cos 3t plus b sine 3t, and to this we add the particular integral. We add negative 2/3, so that's in fact going to be minus 2/3. Now we must remember that we introduced this substitution, x equals root t, so we're not allowed to have any t's in our final answer. But t is equal to x squared. Let's just put this in here, but t equals x squared. So therefore what we've got as the general solution is y equals a cos 3x squared plus b sine 3x squared, and then minus 2/3. Okay, so I hope that's given you an idea then how we can use our substitution, and once we've got our equation that we're familiar with, we can then solve it in the usual way. Alright?